Washington's volcanoes are experiencing the seismic tremors from an unlikely source, and they are glaciers. Jenna Travers from State of the Planet reports, and we're showing you now PNSN earthquakes of the Cascade volcanoes. The first one is very astonishing. Mount St. Helens volcano, 174 earthquakes in the past month, followed by Mount Rainier, 24 earthquakes in the last 30 days. So Mount St. Helens has really picked up in activity. Most people think of seismic activity as a result of movement along faults or of violent volcanic eruptions, but seismic events can have other causes, including floods and even large crowd of excited fans, such as those at Taylor Swift's recent Seattle shows, whose enthusiastic reception caused seismic activity equivalent to 2.3 magnitude earthquake, and also glaciers cause earthquakes. Decades ago, scientists who researched seismic activity in the Washington Cascades recorded a number of small seismic events and eventually determined that they were caused by glacier movement. These events, called glacier quakes, allow for important insight into seismic activity, patterns of glacier movement, and even climate events. For Washington state residents, seismic activity is nothing new. Washington is part of the Pacific Ring of Fire, an arc along the edge of the Pacific Ocean, where tectonic plate interactions frequently lead to more earthquakes and volcanic eruptions. In 1980, Mount St. Helens erupted in southern Washington, causing the most disastrous volcanic eruption in U.S. history. Washington also falls within the Cascadia subduction zone, where a fault line between the Juan de Fuca plate and North American plate threatens a 9.0 magnitude or more earthquake in the coming century, according to geologists. In the Washington Cascades, glaciers are another frequent culprit of quakes, according to Seth Moran, a research seismologist at USGS Cascade Volcano Observatory. When seismologists first set up seismometers on Mount Rainier decades ago, they were nervous when they saw small quakes reminiscent of the ones that preceded the eruption of Mount St. Helens volcano. However, we are, Moran said, eventually able to improve tracking and clearly determine that these quakes were coming from glaciers and not from volcanic activity. So that's good news, right? Using seismometers, researchers identified similar glacier quakes on Mount St. Helens and Mount Baker in the following years, and these have continued to the present day, primarily occurring in the summer months, because glaciers are moving more in warmer months, so we're seeing more of the internal crackling then, said Moran. Washington glaciers are not alone in triggering these glacier quakes. The Alaska Earthquake Center detects between 1,500 and 2,000 glacier quakes per year, some comparable to magnitude 3 earthquakes. Most of these occur in south-central Alaska, and these quakes follow the same seasonal pattern as the Washington glacier quakes. Similarly, many national parks and hiking sites have had growing numbers of visitors following a nationwide spike in outdoor recreation and the end of COVID travel restrictions over the past few years. More visitors mean more people in areas where they might be able to feel some of these quakes, leading to recent media coverage of the glacier quakes. But how exactly do glaciers cause these earthquakes? Jackie Kaplan-Obach, professor of geology at Western Washington University, located just west of Mount Baker, told Glacier Hub that anything that shakes the ground can be recorded by seismometers. For instance, glacier lake outburst floods, which occur when water builds up behind a glacier dam until the pressure becomes so intense that it bursts through, also create seismic vibrations due to the large volume of water suddenly rushing downstream. In the case of glacier quakes in the Cascades, likely causes include crevasse formation, which occurs when the lower part of the glacier moves more quickly than the upper part, spreading the ice until a gash forms, and stick-slip behavior at the glacier ice-rock interface. Kaplan-Auerbach elaborates, saying, as the ice flows, It gets stuck on underlying material and eventually slips forward once the stresses build up to a certain point. That slip is what we record as a tiny quake. In Alaska, calving of tidewater glaciers can also cause glacier quakes. While these glaciers quakes have all been detected on volcanoes, it does not mean the phenomenon occurs only on glaciated volcanic mountains. We're likely seeing these events at these volcanoes because they have large glaciers and/or they are heavily instrumented with lots of nearby seismometers, said Kaplan Auerbach. The combination of these two factors has led groups that track quakes, such as the Pacific Northwest Seismic Network, to show high numbers of quakes around Mount St. Helens and Mount Rainier, where there are several seismometers that can pick up even small quakes, and much fewer around Mount Baker, where there is only one seismometer at a glacier peak. As demonstrated by the Alaskan glaciers, many of which were not on volcanoes, these glacier quakes can be measured in most places where there is a large glacier and a seismometer to track movement. Moran notes that the activity on Mount Rainier was especially interesting to researchers at first. After they determined that the small repetitious quakes were not a sign of impending eruption like at Mount St. Helens volcano, they were able to establish in the late 2000s that the glacier quakes were connected to storm systems in the area. Moran explained that these storms were putting rainwater into the glacier and allowing it to slip more readily for a short time, which increased the frequency of earthquakes. Another interesting glacier quake that researchers are still puzzled over is a repeating quake coming from the Eastern Glacier on Mount Baker. Not only has this quake occurred every day in the same spot for the past 15 to 20 years during quake season, it's also much stronger than other glacier quakes in the area, measuring around magnitude 2 on the Richter scale. The waveform of this quake is identical from event to event, which is unusual for an environment like a glacier, where you would expect a lot of change, Moran said. This identical waveform means the quake is happening in the exact same place and nothing has changed. The ice is the same thickness and the rock is the same composition. This quake is likely the result of a stick-slip behavior of the glacier, but researchers are still eager to learn more about it. Some of these glacier quakes are too small for people in the area to feel, but others, like the repeating Eastern Glacier Terminus quake, has been recorded on seismometers out to 100 kilometers away, said Moran. Maury Pelto, professor of environmental science at Nichols College and science director of the North Cascades Glacier Climate Project, told Glacial Hub that his team of researchers and artists felt the small glacier quakes almost every day during their annual field session in the North Cascades. Pelto has studied the Eastern Glacier for the past 40 years and seen significant terminus at retreat, meaning that the identical waveform glacier quakes must be occurring somewhere on the ice-rock interface other than at the terminus. While these glacier quakes are of interest to researchers, they pose little to no threat to tourists and surrounding communities. John Mutter, professor of Earth and Environmental Sciences at Columbia University, told Glacier Hub that few researchers focus on this topic for that precise reason. One important motivation for studying earthquakes is that they cause damage and deaths. Glacier quakes do not, Mutter said. Although there was initial concern when these quakes were first spotted on seismometers decades ago, seismologists have clearly defined the difference in volcanic activity and glacier activity, and these relatively small quakes are too small to trigger volcanic events. As technologies and access to these areas improve, the data we have will follow suit, allowing seismologists and climatologists to have a better understanding of glacial movement and the overlap of climate patterns and ice flow. This is by State of the Planet, written by Jenna Travers on phys.org. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.